Thank you, Alex, and hello, everyone. I'm actually a veterinarian working in the field of animal welfare for laboratory rodents and rabbits. Within SCIoI, I support my colleagues to better understand the individual intelligence of mice. So try to remember where you last saw a mouse, maybe in the forest, in the garden, on your balcony, or in your house. I think for me it was one of the underground stations here in Berlin. All these areas have in common that they are quite complex, more or less complex, and mice actually manage to live in these different kinds of environments. They can dig very long tunnels and sometimes even tunnel systems. Where one mouse is, there usually are some more animals of this species because they are highly social animals living together in family groups. They support each other, nursing the offspring, and they can learn from each other. For example, where to find food. Depending on how much food is available, they can travel several hundreds of meters per day, and they still find their way back home. And did you know that each mouse has its own personality? And some of these personality traits are more and some are less beneficial when it comes to solving a problem. And mice are actually confronted with loads of problems, with loads of challenges in nature. And they have the strategies to solve these challenges. So are they intelligent? Intelligence has been investigated in mice for decades. It's probably much easier to investigate intelligence in mice than it is in humans, because we can observe a larger number of animals 24 hours, 7, under standardized conditions. However, in research, these animals are often confronted with quite narrow tasks to investigate intelligence. For example, they are asked to push a lever in order to receive a food reward. And you might imagine that a task like this does not really reflect the complexity of challenges the mice are facing in nature. Within SCIoI, we believe in the concept of complex tasks, meaning that we must study complex tasks to better understand the intelligence of the mice. Tasks requiring the mice to use all their skills or all what they can actually do to solve this problem. And therefore, we designed such complex tasks for mice, and we call them log boxes, as Alex has just introduced to you. And there is a food reward hidden under this green element, but all the colored elements, they're blocking each other and deny the mouse access to this food reward. So they have to be opened in the correct order in order to get access to it. So let me show you how it works. First, the yellow lever is lifted, followed by the red stick. Then the gray ball is removed, and finally the green sliding door can be moved to the other side, and usually an oat flake, is hidden under this green door. So you can see, a lockbox is quite complex, challenging the mice with a completely novel task they have not known before. A lockbox requires the mouse to learn new movements, to understand the mechanisms of these elements and the interactions. And for research, a great benefit of these lockboxes is that we can actually measure the problem-solving behavior of the mice. So what do you think? Are mice able to open these complex tasks? On the left side, you can see a mouse that is seeing the lockbox for the very first time. And this mouse had already the chance to work on the lockboxes for a couple of days. So let me start the videos. This mouse is now lifting the lever, and this is now followed by some exploration of the lockbox and the cage. And now I just speed up the video, so the mouse usually do not move that fast. And now she returned to the lockbox and is interacting with the second element on the line, the stick. She's using its paws and its teeth to pull this stick out, because the stick prevented the ball from being removed, and now she should be able to bite into the ball and carry it away. And the mice often focus on these removable objects, like the ball, and they seem to kind of enjoy playing around with them. And after she's placing the ball over here, she is again kind of checking the other elements, and then she's moving toward the sliding door, and then now she can finally enjoy the oat flake. So this mouse actually managed to open this complex task after a couple of days. And when I showed this video to my colleagues within SCIoI, some of them were totally surprised and fascinated that a mouse can open such a complex task, because they would not expect a mouse to be able to do this. But have a look at the other mouse. Oops, go back. This mouse, sorry, now I stopped the video, but you saw this mouse was still interacting with the lockbox, but it has not managed to open any of the lockbox elements so far. So after seeing these two videos, the emerging picture is that the mice actually do get better in opening the lockboxes, these complex tasks over time. However, let me show you how we are actually analyzing the data in order to draw a proper conclusion. So by tracking the interaction zones of these elements, you can identify them by color here, and the head of the mice, we can automatically analyze how often the mice interact with the different elements of the lockbox. And based on our data, yes, we could demonstrate that the mice do get better in opening the lockboxes over time. But how do they get better? How do they learn? Do they simply spend more time interacting with the lockbox? We could rule out that. Do they get better in opening the different elements, the single elements, or do they really get a deeper understanding of the lockbox itself? If they have a deeper understanding of the lockbox, they would not just randomly rattle on all these elements at the same time, but they would rather only manipulate those elements that are still locked. And even smarter would be if the mice would only interact with the elements in the correct order. So to shed some light on this theory, on one day, we only locked the door, or the door and the ball. And if the mice have a deep understanding of the lockbox, they would now only interact with the locked elements. So these mice, you can observe them, they are doing a great job because they are mainly interacting with the door or the ball and the door. For these two mice, we may assume that they actually have an understanding of the lockbox. However, these are only preliminary data of 2 mice, and our data analysis is currently ongoing. So for a definite answer how the mice learn to open these complex lockboxes, you must follow our research activity a little longer, and we keep you updated. And thinking out of the box, the lockboxes do not only contribute to intelligence research. The mice are very, very eager to get access to these lockboxes, and they seem to kind of enjoy playing around with the lockboxes and these elements. Therefore, the lockboxes may serve as a cognitive enrichment for the mice. And this is particularly important in a lab environment, because this kind of stimulation can fight boredom and improve the well-being of the animals. And in other words, the same would happen to Jackson Pollock when he moved from the city to the small fisher village may happen to animals, meaning that the environment can either positively or negatively influence the well-being of them. But now back to intelligence research. When we understand how, when we understand how the mice are opening these lockboxes, we could compare opening these completely novel mechanical tasks. We can compare their problem-solving behavior with other species, such as cockatoos, which are also investigated within SCIoI, and then get a deeper understanding of the intelligence of individual organisms. And remember the concept of different species. And moreover, within the concept of the loop, we could transfer this knowledge, how the mice open these lock boxes, to robots, helping them to open intricate tasks like the lock box. But Manuel will now tell you a little more about this.